Hi guys, so we have started streaming. Just give me a moment to check if I am live. Chetna Kumari, Chetna is here. Okay, that's great. But I cannot see myself live yet. So I have to keep trying and I believe I'm live. Yes. Yes. Now I am live. That's great. I am live, bacha party. So let's get started, guys. Let's begin with you all know that this is Unacademy and we are going to rock together with Unacademy. Correct? This is your channel for ISC and ICSE boards. Just let me check if everything is all right. Yes, it seems everything is okay. No issues, correct? Yeah, you can see myself perfectly. Yeah, I believe no issues. Yes, no issues. Correct. Hi Chetna, how are you? So as you guys know that this is Unacademy and we are going to rock together with the Unacademy ISC and ICSE boards. Okay, let's move ahead. I am using a different pen. My bad. Yeah. Okay. So the next thing is about my introduction. So you guys know me already. I am your chemistry educator, Kirti Sharma, and I have done my graduation from University of Delhi and in psychology, and I have, like you can say, more than 5 or 6 years of teaching experience. I have taught a lot of cute and smart students like you. Okay, so now it's your turn. So what are we going to study today? We will be covering thermodynamics today. What we will be covering today? Just give me a moment to adjust this. It seems okay. I just changed my settings today. So that's why I'm just trying to set everything. Okay. So I believe now it's okay. So we will be starting with thermodynamics. We will be starting with thermodynamics. Clear hai? I believe there is no doubt in this, correct? Okay. I believe that there is no doubt in this. Cool. So we will be doing thermodynamics and today is our lecture number 1. Today is our lecture number 1. Okay. And what else do we know? That before starting, follow Unacademy Champions on Telegram. The group of the, you can say your Telegram group is given to you in the description. And you can just simply, join the session. Join the Telegram group for all the notifications regarding the, like you get all the schedule for particularly class 9, 10, 11, 12 on that group. So you can join it. Okay. Next, we have a very small target of subscribers, that is 1,000. And I believe that this will be, done very soon. Although it's, how many subscribers do we have? It's 404 right now. So I believe it will turn 1,000 like very quickly. I am expecting from you guys. Now, what I have something amazing for you is that there is a deal which is going on these days, and that deal is if you get plus subscription for at least 12 months, for a minimum of 12 months, then you will get extra 3 months subscription for free. Okay, so this is something amazing. You guys can get it. It's very useful for you. It will be amazing. And if you use my code, that is Kirti S Live. My code is Kirti S Live. Okay, Kirti because my name is Kirti, S because it's Sharma, so that's my initial S, and then live because these are the live sessions. So here it is, my code, that is Kirti S live, and you will get an additional 10% discount if you use this code while getting the plus subscription. And there is like one more amazing deal which is going on, like the batch, it will be like started today. That's a new batch, and the name of the batch is Mavericks. Okay, so like as you can see, all the basic information on the screen is given to you, correct? And you can clearly see that it is an all subject batch. The mode of delivery is going to be in English, you know this already. And the most important thing is that like it doesn't matter whether you are in class 11 or in class 12. Shaurya Kohli is asking me, ma'am, is thermodynamics hard? Dekho, I don't feel this, but one thing that I can suggest to you is come daily in the session, and I promise whatever we cover in the session, you will understand that. Okay, you won't feel like कि कोई rocket science है, alright? It is not a rocket science. Very easy, very basic stuff. Okay, you use it in your daily life. Okay, even when आप चाय बनाते हो, that's your thermodynamics. Okay, so if it is tough for you, then we'll make it easier. Don't worry. Alright. Cool, Shaurya. Attend the session and you'll get it, that it's very easy, nothing to worry about. Very easy it is, no doubt. Okay, cool. Let's move ahead. Now if you get class 11 subscription, ISC class 11 subscription, then you are going to get class 12 subscription for absolutely free for that time period. Okay, bindas. Exactly, that's my that's my word. I always say bindas. Okay, that's amazing, that's nice. So these are the deals which are going on, and you can see here these are the deals. So in short, I would just tell you, let me write here, I can tell you, what are the best things to do at this point of time is that, number one, I would tell you to get the subscription for class 11. इससे क्या होगा? You will get ISC class 12 subscription for free. Okay, this is the very first benefit. Number second, if you get the subscription for at least 12 months, get the subscription for 12 months, what will happen? You will get additional 3 months free. So this is an amazing offer. And number 3, use my code, that is Kirti S live, and you will get additional 10% discount. So by using all these 3 simultaneously, you will get major discount. Okay, and before getting plus, you can always watch my special session, and special classes are free for everyone. So you can watch it and you can unlock the free live class by the same code, Kirti S live. Okay, today the session timing for class 11 is 5:15 p.m. on the app and 6:30 p.m. for class 12. So without delaying anything, let's get started with the with thermodynamics. Okay, so yeah, let's get started. We are going to start with thermodynamics. Cool. All right, Shaurya, shall we begin? Okay, so let's get started. Okay, now the very first thing which I would like to let you know is that what is the meaning of thermodynamics. That is the very first question, right, which appears in everyone's mind. So always remember that the Greek word thermo stands for heat. It stands for what? It stands for heat. Okay, so basically thermo means heat And dynamics means like motion, you can say. By the meaning of dynamics, it means motion. Okay, so the motion which is because of heat is known as your thermodynamics, right? You say thermometer, right? Whenever you have fever, you measure your body temperature using thermometer. So again, it is related to heat and temperature. Okay, it is a Greek word. So here thermodynamics is the study of, you can say, different forms of energy. What can you say? That thermodynamics is the study of, it is the study of different forms of energy, different forms of energy. Okay, so it is the study of different forms of energy, and you can say the quantitative relationship between them, and the quantitative relationship, and the quantitative relationship between them. All right, that is your thermodynamics. Okay, the the change which appears because of motion of the particles, they have heat, that's what you call as thermodynamics. Okay, so I believe that there is no doubt in like thermodynamics, correct? Is that okay, Chetna, Shaurya? The meaning of thermodynamics, okay? It basically deals with it is like thermodynamics is the branch of science which deals with different forms of energy and the quantitative relationship between them. Okay, that's your thermodynamics. Very basic, very basic सी बात, ठीक है? Now let's move ahead. If we talk about, like, as I always tell you, that why do we study something? Like, what is the scope of thermodynamics? If I tell you about the scope of thermodynamics, give me a moment. If we talk about scope of thermodynamics, so that is the very first thing which thermodynamics can predict is the feasibility of the reaction. What is it? It is the feasibility of the reaction. Now, what do you mean by feasibility? Whether the reaction will happen or not, that you can predict using thermodynamics. So you call it as what? You call it as, yeah, let me close it. So you call it as what? You say that it is your, just give me a moment to adjust, right? So you can say that it is your feasibility of the reaction. You can write it as here, feasibility of the reaction you can predict, okay, of the reaction. And number second, what else can you do using thermodynamics is, let me get my glasses. Okay, now it seems better. So yeah, so the very first scope of thermodynamics is the feasibility of the reaction, and the second one is, like, you can calculate the extent, like how much the reaction will happen, the extent of reaction. So you can like, the another scope of thermodynamics is calculating the extent, calculating the extent to which a chemical reaction proceeds, to which chemical reaction proceeds. That's another thing that you can say. Alright, now also, like we saw what is thermodynamics. Then in the second place we discussed like what is the scope of thermodynamics, why do we study it. So it comes out that by using thermodynamics you can tell what is the feasibility of the reaction, that is whether the reaction will happen or not, that you can predict. And you can calculate the extent to which like a reaction होगा या नहीं होगा, पता चल गया, पहला scope. What is the second thing? If the reaction proceeds, then to what extent it will proceed. Okay, so that's your scope of thermodynamics. So this was number one thing that we discussed. This is number second thing that we discussed. And number three, now there are some limitations as well. There are some limitations as well. Now what are those limitations? So I would say you cannot predict the speed of the reaction using thermodynamics. Okay, you can't predict the rate of the reaction, the rate, or you can say the speed of the reaction. You cannot rate or speed of reaction you cannot predict. Okay, that is your first limitation. And your number second limitation is that the thermodynamics, the concept of thermodynamics is only applicable for your macroscopic system. You can say that it is only applicable for macroscopic system. For macroscopic system, it does not apply for microscopic system. Okay, it can only be useful in case of macroscopic systems. All right, Shaurya, Chetna, let me know if you have any doubt till now. Is that clear? Is everything clear here? Yeah. Okay. So shall we move ahead, Bacha Party? We did some basic stuff till now, which said that thermodynamics is the study, like it is a branch of science that deals with the different forms of energy and the quantitative relationship between them. Okay, then number second, we studied about the scope of thermodynamics, like why do we study it, what are the things that you can understand. That is the feasibility of the reaction, that is whether your reaction will happen or not. And number second is like if the reaction happens, then up to which extent the chemical reaction will proceed. That's what you can predict. Okay, let's write proceed in a better way. Reaction. Okay. Chemical reaction proceeds. Yeah, now it's better. Cool. Now we can move ahead. The next thing is like we will do some thermodynamic terms, and this is like the very basic stuff. Today is going to be a very basic lecture. It is going to be a very basic lecture, I would say. Okay, these are the basics. Okay, these terms we will be using all the way like in thermodynamics. Okay, that's why it is important to you. Now the very first thing here is it is your system and surroundings. What is it? It is your system and surroundings. So we all know what is the meaning of surroundings. See, if I tell you that this is your system. Okay, if I tell you that this is your system, okay, and here is some, some gases or liquids, whatever, okay. Here is some matter, okay. So now the part like in which you are dealing, okay, the one which is under your observance, okay, जिसको आप observe कर रहे हो, which is under your observation, okay. So that's what you call as your system. If I tell you that here this is your system, here this is your system, all the like inside what is red, it is your system, which is under your observation, it is called as system. Now in everything which is like which surrounds the system, which is, you can say, which is around the system, right, it is called as your surroundings. So the remaining portion is called as the system, and you can see system and surrounding together, they make the universe. What do they make together? They make together as universe. So the universe is equal to system plus surroundings, and everything like which is here, it is your surroundings, okay. SURROUNDINGS, these are your surroundings. So we understood what is a system and what is a surrounding, okay. Now there is something that is you call as boundary. Now as the name suggests, boundary, okay. Now what is the deal with boundary? So you can say that anything which separates the system and surroundings, which separates the system from surrounding, it is known as boundary. Simple. So in this case, I can say now that this is my boundary, because inside the boundary I have my system, and here at the like outside of the boundary I have my surroundings, right. So anything which separates the system from the surroundings is known as what? It is known as your boundary. Now this boundary can be real, it may be real, it may be imaginary as well. Your boundary can be imaginary as well. It can be I would say rigid as well. Rigid भी हो सकती है, flexible भी हो सकती है. ठीक है. So here is the deal with system, surroundings, boundaries. Okay, I believe that there is no doubt till now. Let me know if there is any doubt. As we can see here, what's written here? Look, a system in thermodynamics refers to that part of the universe in which observations are made, right? जिस चीज को भी आप नोट कर रहे हो, जो भी चीज आप कर रहे हो, it is your system, right? And anything apart from the system is what? It is your surroundings, correct? And something which separates the system from surroundings is known as the boundary, and that boundary can be real, imaginary, rigid or flexible as well. Alright, and the universe, as usual, the system on which you are observing and the whole part which surrounds it, it is called as universe. Okay, now it depends, like suppose if I am doing like this is my system, okay, suppose that this is my system, okay, this is also black here, okay, let's suppose this, oops, okay, just give me a moment, my pen dropped. Alright, if I tell you that this is my system, okay, this is my system. Now everything which is present here, everything which is present here is my surroundings, correct? Now the temperature or pressure which is just around here, right, it is the surrounding which is affecting my system. But say if I talk about Africa, it is also my surrounding, but since it is so far, it does not affect my system, right? Because it is too far. So are you getting this? That's the difference between like your system and your surrounding. I believe that there is no doubt till now. Let's move ahead from here. For example, if we are studying the reaction between two substances A and B kept in a beaker, the beaker containing the reaction mixture is a system, and the room where the beaker is kept is its surrounding. The same thing which I just made you understand, right? That's your system, correct? Later on, now we will discuss about the types of system, like what can be the different types of systems, that we will discuss now. So you can see here, note that the system may be defined by physical boundaries. We discussed about boundaries like the beaker or the test tube, or the system may simply be defined by a set of Cartesian coordinates, that from like you took a reference point and then you defined some your Cartesian points, right? Your Cartesian coordinates, and according to them you can like define your boundaries. Okay, the system may simply be defined by a set of Cartesian coordinates specifying a particular volume in space, right? It is necessary to think of the system as separated from the surroundings by some sort of wall, which may be real or imaginary, right? We discussed, we wrote already, right? You can see here that the boundary can be real, imaginary, rigid or flexible. We discussed this, correct? Which may be real or imaginary. The wall that separates the system from the surroundings is called a boundary, right? This is designed to allow us to control and keep track of all the movements of matter and energy in or out of the system, right? Okay, like what is going inside the system, the matter or the energy, and what is like coming out of the system. It is also known as your what like to keep track of matter and energy. Is that okay, guys? I believe there is no doubt till now. Let me know in the live chat if you have any doubt. Clear? We have some water. Okay. Now let's move ahead. We can, okay, so as you can see here, it is your system, it is your like rest of the your universe is your surrounding, and this is the boundary. You can see here that using this boundary you can separate your surroundings, you can separate your system from the surroundings, right? I believe that there is no doubt till now. Let's move ahead. Next is classifications of system, right? So the next is classification of system. So I told you, like whenever you I would say that whenever you talk about boundary, so why did you do that? See, it is already written here. You do that so that you can keep track of the movement of matter and energy in or out of the system, right? This is designed to allow us to control and keep track of all the movements of matter and energy in or out of the system, correct? So only on the basis of matter and energy, right? Whether it can come out or come in, according to these two things, we define the system. What do we define? We classify systems, right? So here you can see that the first one is an open system. It is an open system. What can be the example? What is the meaning of open system? So I would say that whenever your matter and energy both can be exchanged, okay, both can be exchange of energy and matter can be done between the system and the surroundings. If I tell you that I have a cup of tea, okay, all the chai lovers here or all the coffee lovers here, you can imagine it as chai or coffee. Okay, this is my chai, okay, full. Now this is an open system. This is an open system. Why? Because here there can be an exchange of energy as well as exchange of matter between the system. System is our cup is our system, right, and the surroundings, right? So there can be both exchange of energy and matter between the system. So in this case you can say that this is your open system. Okay, the presence of reactants in an open beaker, right, is an example of an open system. You have a beaker which is open, okay, and like whatever the reaction is happening, you can say that it is your open system, because matter and energy both can be transferred from the system to the